Okay guys, I'm going to try to talk a little louder so you can hear me and not fall asleep. Anyways, here is a quick picture of the Pythagorean identities. This is cosecant squared of x. Okay, so these are the main three, and these are how you can change those three around. Basically just by, so for this one, you can get sine squared of x by just subtracting cosine squared of x, and so on. I just manipulated basically these three. Now the special angles, these are angles that are used a lot in calculus, and it's easier to just kind of memorize them. A lot of them you kind of already know, but when x is 0, pi over 6, pi over 4, pi over 3, or pi over 2. You should kind of know these right away when you're solving these problems. Okay, so let's do those last two examples that I didn't do in the previous video. Alright, this one, it looks difficult, but it's really not. So obviously this is a binomial multiplied by another binomial. So what we're going to do is we're going to use the product rule to find the derivative. So that means we're going to take the first guy. So it's secant of x plus tangent of x. And we're going to take the derivative of the second guy. So remember, the derivative of secant is secant of x times tangent of x. And then minus the derivative of tangent, which is secant squared of x, plus, now we're going to take the second guy as he is, so secant of x minus tangent of x, and then we're going to take the derivative of the first guy, and the derivative of secant is again secant of x tangent of x, and then plus the derivative of tangent, which is secant squared of x. Okay? Now, in order to simplify this, yes, you are going to have to FOIL. Alright, so you have to be very careful here because it's obviously a lot to FOIL. So first I'm going to FOIL this first one. So it's the first, so it's going to be secant of x times this whole entire thing. So we end up with secant squared of x tangent of x times the outer, which is minus secant cube of x, times the inner, plus, now I'm going to keep secant first just because that's what I'm writing first, so it's secant of x, but now tangent is squared, and then the last is minus secant squared of x times tangent of x. So that's the first two, okay, these two right here. So now we're going to FOIL these two, and just to save space I'm going to FOIL them right underneath. So this is going to be a plus, and again, first we're going to get secant squared of x tangent of x. The outer is plus secant cube of x. The inner is minus secant of x tangent squared of x. So that's the inner. And now the last is secant squared of x tangent of x, and it's going to be a minus because of this guy. So minus secant squared of x tangent of x. So now what you kind of notice is that you have a lot of very similar terms, so let's see what happens if we try to combine them. So here, secant squared of x tangent of x, just going to lightly circle it. There's another one just like it right over here, and what do you notice? It's subtracted. So what happens to these two terms? They're gone. Okay, next up is the secant cubed of x plus secant cubed of x. What happens to it? It's gone. The next term is the secant of x tangent squared of x, and there's one just like it right here, and you notice that it's subtracted. So what happens to it? It's also gone. Alright, the last term, secant squared of x tangent of x, that's positive, minus secant squared of x tangent of x, and that's gone. So guess what the derivative equals? What's left over? 0. So the derivative of this is 0. So pretty easy. Alright, next up, we're going to find the points on the curve y equals tangent of x from negative pi over 2 to pi over 2. So that's all the ones that we're going to worry about, is the ones that are going to be, I'll just draw a half circle right here. So from pi over 2 to negative pi over 2. So we only care about this part of the unit circle, where the tangent is parallel to this line. So if you remember, two lines that are parallel, what's special about them? Their slopes are the same. Okay? So we know that y equals 2x has a slope of 2. So y equal tan y prime, okay, I wrote this wrong. So d dx of tan of x, so the derivative of tan of x, should also have a slope of 2, right? Because the derivative means the slope. So what we got to do is find the derivative first of tangent of x, and we know that to be secant squared of x, and that has to equal 2. So now we just got to solve this. So you take the square root of both sides. So this is secant of x is going to equal plus or minus square root of 2. Now we could plug this into the calculator if this was on the calculator portion, and do the inverse of positive square root of 2 and the inverse of negative square root of 2, but let's say we don't. Now, what we do know is that secant is the same as, I'm just going to keep going right here. So we do know that secant is the same as 1 over cosine of x. Okay? So now how are we going to get this equation to say cosine of x equals this stuff? I'm just going to solve this algebraically, right? So I multiply both sides by cosine of x. So that way cosine of x is out of the denominator. We get 1 equals plus or minus square root of 2 cosine of x. And now I want to get cosine of x by itself. So I'm going to divide both of these sides by plus or minus square root of 2. Okay? So now we know that cosine of x equals plus or minus 1 over square root of 2. So the question is, where is cosine of what is equal to plus or minus square root of 2? And that is going to be at where x is pi over 4 and negative pi over 4. Okay? And those are the points where the tangent is parallel to y equals 2x. Alright, enjoy. And it was exactly 10 minutes, 30 seconds.